Okay, what's up, everybody? We are, in essence, done with Unit 1. We got through all of the actual assignments. This review is an assignment that you're going to be turning in. However, this is the best preparation for you for the test. And the reason that it is the best preparation is because the questions are, in essence, the same. Well, they're different, but the same type of question. The formatting is the same. It's the same length. This prepares you for the test. So if you know what you're doing with this review, you know what you're doing with the test. So again, if you have any questions or anything as I go through this, make sure you are asking those questions in class and getting the help that you need. Okay, we are going to first start the first part of the test with summations. So here we have the sum of x. So what is on the inside of the summation? Well, x, which is 4, 9, 5, 8, and 2. That is what we are summing. And again, the summation is an addition of those. 4, 9, 5, 8, and 2, which is 28. Not too bad. All right, number 2. What is on inside the summation? Well, it is x times y. So x times y. Again, what you do is you take each number's set by set. So for instance, the first x times y would be 4 times 3. Okay, the next x times y is 9 times 6. The next x times y is 5 times 1. Then 8 times 4. And last but not least, 2 times 6. So those are the x times y's, and then I just go ahead and add those together. And that, my friends, is a summation. When you get to your answer, my advice is highlight the answer some fashion, like square it up or something like that, so I know what is your answer compared to what is your work. All right, next, what is on the inside of the summation? Well, that's y squared. So again, we go through each of the individual y's, and we square them. So this is going to be the summation of 3 squared. 3 squared. Okay, in case you're not like quick with your arithmetic, use your calculator. 3 squared. There it is. 3 squared. 9. Okay. Next, 6 squared. 6 times 6 is 36. Next is 1 squared. 4 squared. 6 squared. And then we add them up. Okay, next. What is on the inside of the summation? Well, it's just straight up y itself. Y. Y is on the inside of this summation. Okay, so this is the summation of y squared. So the summation of y is 20. Okay, so that's the summation of y. But that's not the entire problem. So we're taking the summation of y squared. All right, number 5. Sorry, I'm working so low on the screen here. 5 is the summation of x plus y. So again, take it individual thing by individual thing. So the first is the 4 and 3. So x, 4, plus y, 3. 4 plus 3 is 7. Then I have 9 and 6. And then I have 5 and 1. Then I have 8 and 4. And then I have 2 and 6. So those are those. Now I have the inside answers, so those are the things that I sum up. Right, number 6 is x sub 3. So again, what that means is that is the third x sub 3. It's not x to the third power. Okay, so x to the third power is not the same thing as x sub 3. Those are two different things. What x sub 3 is the third x. So if this is the first x, second x, third x, fourth x, fifth x, etc., the third x, x sub 3, is the number 5. So this is straight up the number 5. That's sitting right next to, so that implies multiplication, the sum of x squared. So here I go through each individual element of the x, and I square it. So 4 squared, 9 squared, 5 squared, 8 squared, and 2 squared. And then last but not least is I multiply the two different things together. So the 5 times 190. All right, number 7. What I see is the numerator is x times y. So if I did number 2 correctly, that numerator should be 115. The denominator is the sum of x. So again, if I did number 1 correctly, that should be 28. So top divided by bottom, 4 decimal places, so 1071. Notice how I do not round that 1 up to a 2 because the next number beyond that is a 4. So 4 does not give that. It's a small number, so I don't round it up. All right, 8. X sub 2 is the second number of x. So the second number of x is 9. Y sub 3 is the third number of y, and that is the number 1. So this is the square root of 9 divided by 1. So the square root of 9 divided by 1 should be 3. Okay, the summation of x, this is number 9. The summation of x is 28. Again, if I did that correctly. Summation of y, if I had done number 4 correctly, is 20. And the denominator is x sub 5. That is the fifth number of x, and that is the number 2. So the numerator is 28 times 20. The denominator is 2. Thus, this actual answer is the top divided by the bottom of 280. Number 10. How am I going to do this? Here's what I'll do. Take a snip. kind of work off of here. So the first one is the sum of x squared y. So the sum of x squared y, sum of x squared. So the first one is the 4 and the 3. So the x squared times y. 4 squared 3, 48. Next one is the 9 and the 6. So x squared y. Next one is the 5 and the 1, x squared y. The next one is the 8 and the 4, so x squared y. Next one is the 2 and the 6, so x squared y. $839. Okay, so that is that first summation. The next summation is going to be the sum of xy. And so again, I believe I already have that. The sum of xy is 115. So what am I going to do with that? I'm going to square it. So 115 squared is that monstrous number. And then I'm going to divide it by 5. Two, 6, 4, 5 is that second bit. So the complete numerator is the summation of x squared y, so that's the 839. And the second bit is the 2, 6, 4, 5. So add those two things together. I see that the complete top number is 3,484. The bottom is 5 minus 1, 4, and then don't forget that there's a square root involved. So this problem is going to be the square root of 3,484 divided by 4. Notice how it is all inside the parentheses. Make sure you're using parentheses. And I just need to kind of adjust my screen here so I can kind of fit my answer in. So this is equal to 29.5127. Booyah. Next, the sample was constructed to determine the availability of parking. The first 100 people, did you have trouble finding parking? Was this a sample random or biased? This is biased. Again, if you want to know about all these people, but you only ask the first 100, you're not getting a fair representation of the entire population. Because what you already know the answer before you ask the question. Do you think that the first 100 people had problems finding parking? No! Parking lot was empty. Not everybody had a chance to be asked. A sample is constructed to determine the popularity of pizza in your school. 5 random students in the 3rd hour classes were asked, do you like pizza? Was this sample random or biased? Okay, what you need to know is everybody has a third hour class. So if you want to know about your school, who likes pizza in your school, and random people were asked in their third hour class, that means since everybody has a third hour class, you are asking a random sampling of everybody. This is absolutely random. Okay. Everybody had a chance to be asked. All right. Next. You want to know how many Americans like soccer? Would you take a census or a sample? So again, don't be distracted by the question itself, okay? Don't be distracted by the question. When you're looking for a census or a sample, you want to know about the population. So the population is how many Americans. Americans is the population. Okay, so Americans is a very large population. Millions and millions of quote-unquote Americans. So would you take a census or a sample? Well, since it's so large, you would need to take a sample. You need to cut that down to something more manageable. Yes, you want to take a census, but again, census means you ask 100% of the population. So I don't have that kind of time. So sample, why? Because the population was too large. It was too big. Okay, number 14. You want to know how many players on your school soccer team wear Adidas shoes? Okay, so again, don't be distracted by the question. You need to be focused in on what is the population. Who do you want to know about? You want to know about the players on your school soccer team. That's the population. So how many people? What is the population size? Well, that's relatively small. That's, 30 people or so, like across the levels. So the population of that is relatively small. So you can ask 30 people about that. And so what you can accomplish is you can accomplish your census that you want to take because it is relatively small. The population is manageable. Okay, quantitative or qualitative. Quantitative is a measurement. Qualitative is things that aren't measurements, like they're categorical things. The coffee had a robust aroma. There is no measurement in that. That's a quality of that coffee. All right, identify the variable as being quantitative or qualitative. And number 16, the coffee was a 12-ounce latte served at 150 degrees. There's all sorts of measurements all over that thing. That's a quantitative. Okay, those are measurements. Okay, and last but not least, I believe these are going to be percentage problems. Again, if you do not have a percentage and you need to create one, you need to make a percentage, you divide. Okay, to use a percentage, you multiply. All right. A student got 56 questions correct out of 70. What percentage did he or she earn? Okay, I don't have a percentage. I need to create one. That's what the question is. What percentage? And so I need to make it. Thus, I need to divide. So that is 56 out of 70. 56 divided by 70 is 0.8. Move the decimal 2 decimal places. That turns into, well, 80%. Number 18, a student got 13 questions incorrect out of 52 on his or her test. What percentage did he or she earn? This is a trick question. All right, so the student got 13 questions incorrect. So you don't get a percentage on the numbers that you get incorrect. You get a percentage on the numbers that you got correct. So if there were 52 questions on the test, they got 13 of them wrong. Don't do 13 out of 52. That's an incorrect way of doing it, because that is the percentage that they got incorrect. We don't want to give them a percentage incorrect. We got a percentage correct. All right, so if they had 52 questions, got 13 of them wrong, that will leave 39 that they got correct. So this is going to be 39 correct out of 52. .75, move the decimal place 2 places. That implies 75% correct. Number 19, a basketball player makes 73% of his or her free throws. During the season, the player shot 126 free throws. Approximately how many should he or she have been made? All right, so again, we aren't making a percentage. We have a percentage. We don't need to make one. We need to use one. We're taking 73% of that 126. So to use a percentage, we multiply. So the first thing we do is we take the percentage as a decimal. So 73%, move it 2 decimal places. That would be 0.73. 0.73. 73% of, multiply, 126. That makes more sense. So again, leave me the math answer. Don't round. Okay, don't turn that into 92 or something like that. Give me the math answer. Give me the decimal answer. And so this player would have made 91.98. %8 of the population is left-handed. There are 2,025 students in your high school. Approximately how many of them should be left-handed? So again, we are not creating a percentage, we have it. So we are taking 8% of that 2,025. So 8%, so think about this, 8%. Move the decimal place 2 places. And so 8% is 0.08. Don't accidentally say 0.8. 0.8 would imply 80%. This is 8%. So 8%, 0.08 of 2,025. $162. Looks like the last question. During a study, you found that 14 out of 32 like Justin Bieber. If there are 2,025 students in your high school, approximately how many of them should like Justin Bieber? So this is a question where we have to do both things. We need to make a percentage, and then we need to use a percentage. Okay, so the first thing is to create our percentage, and that is 14 out of 32 people like Justin Bieber. So 14 out of 32 is 0.4375, okay, which is the same thing as saying 43.75%. But that's not the question. I'm not really using this number at all, okay? Because now that I have the percentage, now I need to use the percentage. So if that percentage likes Justin Bieber, now I have a percentage and I need to use it. I need to know what is that 43.75% of 2,025 students. So 43.75 of 2025 implies that 885,937.5 like Justin Bieber. God, that's scary. Anyways. All right, so that is your review of the test. Again, the test itself will be pretty much a copy of this. Obviously different numbers and things like that, but if you know how to do these problems or you're comfortable doing these problems, then the test should be just fine. Again, if you need to rewatch this or if you have any questions, please let me know. I want everybody to be very successful with this first test. When the test actually is or whatever, stand by. I'll let you know on the Google Classroom when the test is and how we're going to be taking the test and things like that. It's information that I don't have right now, but I will get to you as soon as I know. All right, have a good day, everybody. Keep smiling.